All right, so here's a video on the review in case you have any issues. So the first question we're going to look at is number 2. So with this one, you just have to simplify and state what the excluded values are. So simplifying for number 2 is usually not bad. On the top, we just have a GCF problem. So we're going to factor out the GCF of 10, and then we get n minus 1. We have 50 on the bottom. And then you can't touch the parentheses as far as simplifying goes, but you can simplify the GCF with the denominator. And so we can divide 10 and divide by 10. And then our final simplified answer would be n minus 1 over 5. The question that I often get from students is, how do you find an excluded value in the denominator if there's no variable down there? And the answer is there isn't one. So there is no excluded value in the denominator, and that's because there's no variable to plug a number in for. So the bottom would never become 0. So just a reminder, excluded values are values that would make the denominator equal 0, and that would never happen in number 2. All right, the next problem I want to go over is number 6. This is a division problem, so we're going to do keep it, change it, flip it. So I'm going to keep this fraction the same, change it to a multiplication problem, and then flip the second fraction. And then when we look at this problem, the part that's a little bit weird is the 10 minus 3x and the 3x minus 10. They're similar, but they're not identical, so they do not cancel out. And here you just have to remember that when things are written in the wrong order, we have to fix the order. So this parenthesis should be negative 3x plus 10. That's what should be in the parenthesis. And then because there is a negative in the front, we would have to factor out that negative. And then that parenthesis would be positive 3x minus 10. So what we're going to have for the first fraction is 9x on the top. Then we have that 3x minus 10 in the parenthesis. And in front, we already had a 3, and now we also have a negative. So I'm going to have negative 3. And then I'll go ahead and just copy down the other fraction over here. So now you can see that the parentheses are identical, and so now we can cancel them. Then we have a 9x and a 9x, and so what's left over is 2 on the top, negative 3 on the bottom. Most mathematicians would not leave the negative 3 on the bottom. They would take the negative and move it to the top and call this negative 2/3. Either one of those answers is totally fine. They're both mathematically accurate. Okay, the next problem that I wanted to look at is number 15. So for 13 and 14, we are adding or subtracting fractions and getting a common denominator, but 15 was a little bit trickier than 13 and 14, which is why I thought I would do 15 instead. So for 15, we have to make sure to factor the denominators. So for 15, the first fraction, we're going to factor using difference of squares. So the denominator is x plus 2, x minus 2. For the second fraction, the denominator is just x minus 2. And so that means that for the common denominator, the two pieces for the common denominator would be x plus 2, x minus 2. And what I have found is that usually students understand how adding and subtracting fractions works until we get to the complex fractions and solving equations and stuff, where we get to ditch the denominators, and then they start to forget which types of problems we get to ditch a denominator and when we have to keep a denominator. So what I want for you to do is draw a line across here in your review packet. So Above this line, we're going to keep the denominator. Below this line, we can ditch the denominator. So here we've got, these are the complex fractions. We can ditch the denominators here. Ditch the denominators. We're solving equations. We can ditch the denominators. If we go back here, we are adding and subtracting fractions. So I'm going to draw a line here. This is where we are keeping the denominator. And I'm going to say common denominator specifically. We're keeping the common denominator. So above this line here, so 13 and 14, above the line for 13 and 14, we don't need a common denominator. So students start to lose sight of that big picture perspective sometimes by the time we get to the review. Okay, so we do need a common denominator for 13 and 14. We cannot ditch the denominator once we get it. Okay, so for 15, we factored the denominator. We figured out that it was difference of squares. We have x plus 2x minus 2. Over here we have x minus 2. So that first fraction has the common denominator, so I'm just going to copy it down. 2x plus 4 with x plus 2, x minus 2. That second fraction, however, does not have the common denominator, so it only has x minus 2. So that means we're going to have to multiply the top and the bottom by x plus 2 to get the second fraction to have the common denominator. So now I'll go ahead and write down what my two fractions are. So this would be x squared plus 2x. Okay. And so now I can write this down as one fraction. So the denominator is x plus 2, x minus 2. And then on the top, I have x squared. And I'm adding these two fractions together, so I'm not too worried about doing this all in one step. 2x and 2x is 4x. And then I have a 4. So now I can go ahead and do my factoring. So I'm looking for two things that multiply to 4 and add to 4, and that would be 2 and 2. So on the top, I have x plus 2, x plus 2. On the bottom, I have x plus 2, x minus 2. So these factors are identical. They cancel out. These ones look very similar, but they don't cancel. So my final answer is x plus 2 on the top, x minus 2 on the bottom. And that's it. Okay. For number 16, same thing. I'm going to factor the denominator. So this one is just 2 and n. Over here, I'll take the GCF out, a 2n, and then n plus 4. So my common denominator, I would need the 2n because both of the fractions have that. And then I would also need n plus 4. So it looks like my second fraction has the common denominator. My first fraction is going to need the n plus 4. So I'm going to write my first fraction and multiply it by n plus 4 on the top and the bottom. And then with my second fraction, I'm going to go ahead and just write out what I have. So here I have 6n plus 24, 6n plus 24 over 2n n plus 4. And now I can go ahead and write this as one fraction. So I'm going to copy the first one down. And this is a subtraction problem, so I'm going to distribute the negative. Minus 2n minus 8. So 6n minus 2n is 4n. 24 minus 8 is positive 16. And so now if I factor the top, I have a GCF of 4. And then I get n plus 4. Okay. And so now the parentheses will cancel. And if I look at my GCFs, those can reduce as well. They're both divisible by 2. So I get 2 over 1n, or just 2 over n. Okay. Next, I wanted to look at complex fraction problems to make sure that those were comfortable. So first we'll look at number 18. So we have a fraction and a fraction, a whole number 4, which I'm going to turn into a fraction. I'm going to write that as a 4 over 1. So I'm going to look at all my denominators and figure out a way to find the common denominator between them. It's helpful if they're in factored form when I do that. So u plus 3 is kind of already a factor on its own. 2u plus 6 is actually the same thing as 2 times u plus 3. So these two denominators are actually really similar. I'm going to scribble that out and think of this as 2u plus 3. So my common denominator is going to be a 2 and a u plus 3 because the 1 doesn't really help me out with the common denominator. Okay, so now what I need to do is I need to take this entire thing and I need to multiply it by my common denominator. I'm going to multiply it by my common denominator on the top and on the bottom. So 2 times u plus 3, 2 times u plus 3. So I'm going to multiply every single term. So this term and this term and that term. So u over u plus 3 is being multiplied by 2 times u plus 3. 6 over 2 times u plus 3 is being multiplied by 2 times u plus 3. And then 4 over 1 is being multiplied by 2 times u plus 3. Okay. So in the first term, the u plus 3's are canceling. And I just have u times 2, so I just have 2u. In the second term, the 2's cancel, the u plus 3's cancel, and I just have plus the second term, so plus 6. And then on the bottom, I have 4 times 2, which is 8. 8 is being distributed to the u plus 3. So 8u plus 24. 8u plus 24. So now I can factor what's on the top and the bottom just to see if anything can reduce. So when I factor the top, I can take a GCF of 2 out, and I get u plus 3. On the bottom, I can take out the 8, and I kind of just undo the distribution that I did. So take out a GCF of 8, that leaves me with u plus 3. So the u plus 3's cancel, and then 2 over 8 is actually 1/4. So, okay, 1/4. Got it. All right. I also wanted to do number 19. I think number 19 is one that students have asked me about. It's kind of similar to number 18, but it's different enough we can do it. So again, this is a whole number on the bottom, so I'm going to put it over 1. Again, m plus 1 and 2m plus 2 are similar, but 2m plus 2 is not factored, so I'm going to factor that. I'm going to take out a GCF of 2. 2 times m plus 1, so I can kind of see how similar those are. Okay, so my common denominator between these two denominators would be 2 and then m plus 1. So now I'm going to multiply by the common denominator on the top and the bottom. And I'm going to multiply by that for each of these terms. So I'm going to have m squared over m plus 1 times 2 times m plus 1 plus m over 2m plus 1 times 2m plus 1 over m squared times 2m plus 1. Okay, so let's see what cancels. So the m plus 1s in the first term cancel, and I get m squared times 2, so that's 2m squared. And I'm adding the 2 and the m plus 1s cancel, so I'm adding m. And then on the bottom, I have m squared and 2, so I have a 2m squared that's being distributed. So 2m squared plus, 2m cubed plus 2m squared. Okay? And then at this point, I can factor out a GCF on the top and the bottom and see if anything can cancel. So on the top, there's a GCF of m, and then I'm left with 2m plus 1. On the bottom, there's a GCF of, well, it's right here, right? 2m squared. And then I'm left with m plus 1. Feels like the parentheses should cancel, but they won't. Okay, so I can simplify a little bit. I can take an m out of the top and one of the m's out of the bottom. And I end up with 2m plus 1 and then 2m times m plus 1. That's as simple as it gets. Okay. All right, next page. On this page, I wanted to look at problem number 23. So we have to figure out what the common denominator is. So we need to look at the factored form of the denominators. So here we have n times n minus 6, just an n. And then here we have an n times n minus 6. And so with an equation, we're going to multiply by the common denominator. So if the common denominator here, the common denominator would be just the single n, but also the n minus 6. And then remember, when we're solving an equation, we also want to look at the denominators, and we want to make sure we know what the excluded values are. So what are the numbers that would be problematic and would make the denominator of one of these fractions become 0. And so the denominators that would be an issue, or the values for n that would make the denominators an issue, would be 0 and 6. Those are the two values that we can't have. Those are our excluded values. Okay, so now that I know what my common denominator is, I'm going to go ahead and multiply my common denominator by each of the pieces of the equation. So I have 3 over n times n minus 6 multiplied by n times n minus 6 plus 1 over n times n minus 6 equals 1 over n times n minus 6 times n minus 6. Okay, so the equation is going to be 3 plus n minus 6 equals 1. That's an easy equation. Okay, n and a negative 3 equals 1. Oh, n equals 4. And then we just make sure that our answer is not one of the excluded values, and it's not, so our answer is good. Okay. All right, I wanted to do one of these just to make sure that we're comfortable with finding all of the things. So 25, find the transformations. Okay, so we've got reflect over x, right 2, up 3. Okay, find the asymptotes. We've got a vertical asymptote and a horizontal asymptote. The vertical asymptote is 2. Horizontal asymptote is 3. So now I'm going to go ahead and graph this. Vertical asymptote is 2. Horizontal asymptote is 3. I'm going to type this in to my calculator. -1, over x minus 2 plus 3. So I'm kind of looking for 2, 3 on the table, so I can see that that's where the asymptotes come together. If I don't want to graph fractions, I can hit the y equals button, go to the end of my equation, hit the math button, and go to decimal, and then hit second graph again. Oops, just kidding. I needed to go to decimal and actually press enter. Okay, math, go to decimal, press enter. There we go. Now it will turn all my outputs into decimals. There we go. Okay. So I've got the 0.14 over 1 up 4. 0, 3.5. 3, 2. 4, 2.5. Okay, so there's my graph. Domain and range. So from left to right, I'm going to have all of my values except for 2. So domain is negative infinity to 2, 2 to infinity. For up and down, I'm going to have all of my values except for 3. So negative infinity to 3, 3 to infinity. And remember that the range for these graphs and these graphs are different. These ones have both of the curves above and below the asymptote. The squared graphs have the curves right next to each other, so they would either be both above or both below. And you don't have 2 pieces for your range, you only have 1. So be careful of that. We have the increasing and decreasing intervals. So since my intervals look like this, if a stick figure started walking, here he would be walking like out of a valley, but up and out of a valley. So here is my negative infinity to my vertical asymptote at 2. So this is increasing, walking up out of a valley. And then he walks up into the heavens, I don't know, and burns to a crisp. And then this other stick figure crawls out of the fiery depths. I don't know. He crawls out of the vertical asymptote, and he crawls up and over a cliff. But he's increasing, and he increases to a right arrow, which is positive infinity. So there are two increasing answers, negative infinity to 2 and 2 to infinity. And for decreasing, we're going to say none. Okay. They didn't ask for the max and min, but if they had, there's no mountaintops or valleys for these graphs. We're going to find the x and the y intercepts. So if I look at the picture, I can see that the x-intercept is going to be to the right of the number 2, and there's only one x-intercept. So it's to the right of 2, so I'm going to do second trace, option number 2, and then when I do my left bound and right bound, I'm going to look to the right of 2. So from like 2 to 4, left bound 2, enter, 4, enter, ignore the guess, and press enter one more time, 2.333. Okay. The y-intercept, I'm going to do second trace, number 1, and plug in 0, 3.5. Okay. The end behavior. As I look at the left arrow, as I look at the right arrow, remember in this unit the end behavior is easy, because the arrows don't go up or down when you look at the left and when you look at the right. They always go to the horizontal asymptote, and so that's the number on the end. So both of these are going to go to 3. Don't even have to look at the graph to get that right for this unit. Okay, I wanted to look at one last problem because this does throw students off on this unit. So I'm going to do problem 29. It says, working alone, Castell can sweep a porch in 12 minutes. One day his friend Catherine helped him and it only took her 6.24 minutes. Find how long it would take to do... Oh, it took 6.24 minutes for them to do it together. Find out how long it would take Catherine to do it alone. So we have Castell did 1/12 of the job per minute. Catherine, we are not sure, so she did 1x of the job per minute, and then together they did 1/6.24 of the job per minute. So we're going to say 1/12 plus 1/x equals 1/6.24. And if we were trying to find what the least common denominator was, that would be kind of hard here because we got 6.24, it's a decimal, and that really threw students off. And so what I ended up telling students to do with this problem, since it's a decimal, is just to take the 12 and the 6.24 and multiply them together, 74.88, and just say that the least common denominator is 74.88x, and leave it at that and don't get caught up in it. It's not a big deal if your least common denominator is a decimal. So I multiplied them together and then I called my least common denominator 74.88x. It's not a big deal. It works out just fine. So I'm going to go ahead and show you guys how in the problem we'll be okay if we do it like this. So I'm going to do 1/12 times 74.88x plus 1/x times 74.88x equals 1/6.24 times 74.88x. So if we do 1/12 times 74.88x, we get 74.88 divided by 12, which is 6.24x, so that makes sense. 6.24x plus. If we do 1/x multiplied by 74.88x, the x's end up canceling. We get 74.88 If we do 1 over 6.24 times 74.88x, we would get 74.88 divided by 6.24, which is 12. Okay, that makes sense. 12x. So I would subtract my 6.24x over to the other side. So the problem works out exactly the way that it would if you didn't have decimals. It's just doing the problem with decimals instead. So 12 minus 6.24 is 5.76x. And so now I'm going to do 74.88 divided by 5.76. And it works out to be a whole number, which makes sense because it's like they did the problem with the whole number first and then kind of got the reverse answer or something. So 13 equals x. So how long would it take Catherine to do the sweeping of the porch alone? It would take her 13 minutes. So 13 minutes. It didn't tell you to write the answer in a sentence, and I'm running out of room. So 13 minutes. The way that the problems are phrased, 27 and 30 do not ask you to do that with a decimal, but 28 does. So, okay. I think that is all as far as if you have seen those, then you can be successful with the test review.